Hi everybody, welcome to another video in differential equation, section 2.3 linear equation. So this section is very important. It should be one of the last thing you forget about this class. Right, so linear equation, to be more precise, this is linear first order equation. So a linear first order equation is the equation in this form. So what we have is we have the derivative, and we have the function in this form, where a sub 1 of x, a naught of x, and b sub x, those are function of x. Or in standard form is given in derivative plus a function times y equal to a function of x. Now, the solution will be given according to the standard form, so this is more important that we know the standard form of the linear first order equation. It is first order because we have the first derivative. It is linear because there's no square here. We just have y and derivative of y, and that's it. No y square, no square root of y, no sine of y, nothing like that. Right. So the solution will be in this form. Right. So that is the problem. What is the solution? So the solution, by the way, this is the formula for it. But like I said, I hope that this is one of the last thing you forget about the class. So it is more than just memorize the formula, right? So we just need to understand how do we arrive the solution rather than just memorize that. I don't even memorize that. I just derive the formula every time because it's not that bad at all. So first, we start with the equation in standard form. So this is where we start with. And then we will let mu of x equal to e to the integral of the coefficient of y. And that called the integrating factor. Why we integrate that? After we integrate that, we multiply both sides by integrating factor. So why do we do that? So when we multiply both sides, we rewrite it like this. Now, what it looks like here is we have the integral of e to something, and then derivative, and then we have that and y. If we rewrite this, if I put in this form, u v prime, and then u prime v. Of course, if it is like this, then that is the product rule. Yeah. So derivative will be the first and then the second, not second and first. It doesn't matter. But the left hand side is the product rule. So we write in this form u and y, u and v. So left hand side product rule is that. Now we have the derivative. The key here is we have derivative equal to something. If we want to undo the derivative, of course that is the antiderivative, or the integral is 4. So integrate both sides, and we end up with this. Integral of this have a constant. And finally, to get y by itself, we divide by the integrating factor. After that, we divide integrating factor both sides. And we have this solution. Like I said, formula is good and all, but I don't even memorize that. I will derive the formula every single time. Just keep in mind that what we need to do is finding the integrating factor, which is this. In order to find integrating factor, we need to know p of x. So that's why we need the equation in the standard form, so we know exactly what is p of x. Right. And the method for solving linear first order differential equation, write the equation standard form, find the integrating factor, multiply both sides, and then we write that using the product rule, and then integrate both sides. So that's how we write the solution. Right. So let's look at a first example. The first example. Right. I'll find the general solution to this equation. Right. So first, we need to write this in the standard form. So this is not in standard form. The standard form has derivative and then whatever after that. So we have standard form here. That's what we need. After that, we write p of x. Or we can write as -2 x to -1. Now integrating factor is mu to the e to the p of x dx, and so integrate the integral of -2 x to -1 is -2 ln of absolute values of x. Don't forget there's an absolute values here. Right. And the properties where we can take the exponent inside. So I will write a little more stuff here. So first of all, we have these properties where we have ln of m when constant in front. We can take that constant in front, move inside as the power. So that's why the -2 here move into x here. Right. Yeah. So there's actually, yeah, certainly we can do that, but let's write in two different ways for this step to this step. So e to the -2 ln of absolute values of x. Right. What we can do is we can take the -2, bring inside, and we end up with e ln absolute value of x to -2. And then we use another properties of e to ln of m. E and ln cancel out is equal to m. I think we wrote this on the previous section, but we use those two properties. This cancel out. End up with x to -2. Yeah, there's x absolute values there. So that's one way to think about that. A second way to write this as, remember, if we have power to another power like b to the m to the n, right? It's going to be equal to b to the m times n. Right. Now we have -2 times ln of x. So this is just e to the ln of x, and then to -2. So that this step from here to here, I use these properties. B to the m times n is equal to b to the m or b to the n times n. So from here to there. Or you can use those two properties either way. Right, and e, so the -2 times ln of x, -2, bring it on the outside and cancel out. We have absolute value of x to -2. And then y in the note, I didn't have the absolute values. Well, that's another step. Right, x to -2. Right, and that is just 1 over x squared. Of course, it's just x to -2. Right, why is that? Because absolute values it's going to be positive square, right? So it's positive square, so it's still square. It doesn't matter whether it's a plus or minus, right? Because in the absolute value of x, could be x. If x greater than equal to 0 and it is equal to negative, or opposite to x if x is negative. By the way, x is positive in this case, so we don't even worry about that. So that's why we don't even need absolute values. But so from here to there are two rounds. We use those to go to this step. In ln cancel out. We see a lot of this, and then cancel out. Right. Part of differential equation is sometimes we have to do enough problems in order to do more problems, because there's some certain technique and certain things that we have to watch out for, and the e to the ln, you see that more often than not. Actually, we see that quite a few times. I just leave it at that. Right, so we have x to negative 2, that is integrating factor, multiply both sides by that. So I multiply both sides of the equation by the multiplying factor. Multiply this out, and then the left hand side I'll just write the integration factor and y, so x to negative 2 and y, just that. The right hand side cancel out cosine, and then integrate both sides. The integral undo the derivative, so we just need to integrate cosine of x. Integral cosine is sine x plus c, and then that's what we have, and then multiply x squared on both sides. We have that. So the most important thing here is in the standard form, so we can write the integrating factor and we go from there. Right, there will be quite a few examples that we have here. So first is the second example. Let's look at this. That equation, not in the standard form. The standard form has derivative, something times a function, and then something else. So I'm going to move to e to negative x to the other side. So this in the standard form, y prime plus 4y equal to e to the x, right? Move that to the other side. So this is in the standard form. Where the coefficient that go with y is just 4. Right. So we need to write that in standard form, identify what is space of x. After that, we can find integrating factor. This is the most important step of solving the linear first order equation. Integrating factor. Mu of x equal to e to the integral of px dx. So we have e to the integral of p of x, which is 4 dx, integral of 4x. 4 is e to the 4x. We don't need the constant c here. Yeah, we'll talk about that in a minute after this one. Why don't we need the constant c there? Right, so we have integrating factor, right? Now multiply both sides. So the integrating factor is e to the 4x. I multiply both sides. And sorry, this is e to negative x, right? So this should be e to negative x. Sorry, I forgot. Still e to negative x. Sorry. Right, and we still multiply e to the 4x on both sides. Right, now this will be the chain rule, product rule. So, and let's just put the product rule once again. Is this one, right? It's where that u v prime plus u prime v, or u prime v plus u v prime. So we have uv derivative for the 1 and then 2. It doesn't matter how you write it. So here I can say this is derivative and this is the function. So obviously we should let this one, this is obviously going to be v prime and the other one is v, and this going with the v is going to be u prime, and go with the v prime is going to be u. So as you can see derivative of e to the 4x is e to the 4x times 4. So that's why we multiply integration factor both sides. So that gives us the product rule on the left hand side. So the left hand side is the product rule. So we can write u derivative of uv. So we have the big derivative of u, which is e to the 4x, and then v, which is y, equal to e to the 4x times e to negative x. That is the properties. So we can add the exponent. So that gives us e to the 3x. Right. Now, if we want to get rid of the derivative, that is antiderivative, so we integrate both sides. So integrate, we undo the derivative. So the left hand side just e to the 4x times y, integral of e to the 3x dx. Integral of e to the 3x is e to the 3x and then divide by 3. So that is the left hand side is still the same. Integral of that is 1 over 3 e to the 3x plus c. And finally, to solve for y, we just divide e to the 4x on both sides. So next, solve for y. Meaning that we divide e to the 4x both sides. But divide by e to the negative 4x is the same as or multiply e to the negative 4x on both sides. Okay. Instead of divide by e to the 4x, we multiply by e to the negative 4x. Right? So because I say we have e to the 4x, instead of divide by e to the 4x, we can move that to the top. It becomes e to the negative 4x, right? So e to the 4x at the bottom, move to the top, becomes e to the negative 4x. So that's why instead of divide by e to the 4x, we multiply by e to the negative 4x. So we have e to the 4x y, and we multiply e to the negative 4x in front. And e to the negative 4x and e to the 4x, we can still use that properties. We add the exponent, so e to the 0 power negative 4x plus 4x is e to the 0 power, which is 1. So we just have y equal to multiply these two, we add the exponent negative 4x plus 3x negative 4 plus 3 is negative 1, so we have 1/3 e to the negative x plus c e to the negative 4x. Right? So that's what we have. So it's not that bad. So most of the problem, we have this step. Integrating factor, multiply both sides, turn to a product rule, integrate to undo the derivative, and then at the end, get the y by itself. Right. Now I did mention that at this step, why don't we need the e to the c? We don't need the constant, right? So let's assume that we still write a constant. What will happen? Let's say, so there's some certain things that even, I mean, by the way, when I have this note, I combine at least 3-4 different textbooks together and pick out the nice example. And even in those textbooks, they don't explain very well why don't we need the constant c and why don't we need absolute values and those kind of things, which I'll tell you all of that. But at this step, why don't we need the constant c there? All right, let's say if there is the constant c, so suppose the integrating factor instead of e to the 4x, this is e to the 4x plus c, right? And we did this on the previous section. E to the 4x plus c is e to the 4x times e to the c, and we still use the same properties here, but going from the right hand side to the left. So that's what we have. C is a constant, e to the c is also a constant, so I can just say this is a constant e to the 4x. So the integrating factor could as well be c e to the 4x, right? And we multiply both sides. So instead of this equation, I will have c e to the 4x y prime plus c e to the 4x 4y equal c e to the 4x e to negative x. Yeah, so if you want to, we can just do it like that. There's nothing wrong there. However, in this equation, because all of them have c, so we can just divide by c on both sides, and that cancels out. So that's why in this problem, whether we have plus constant c in the integral or not, it doesn't matter. Quite often than not, we just ignore it and we don't write the plus constant c there. Most of the book don't explain why we don't need the constant c there, and this is why. Yeah, because c cancel on both sides. Yeah, so and that's why when we do the integrating factor, don't need the constant c there. At the same token, even though in this problem there is x greater than 0, so that's why we don't need the absolute values. But in general, we don't even need absolute values. Yeah, this problem is not very clear, but on the next one, you see. We'll get back to that. Once again, for integrating factor, whether there's absolute value or not, we can just ignore it. It still doesn't matter. You see. Right. So, but what's the problem? We do like this. Right. More examples. Right. Solve the initial value problem. This. By the way, this equation, if I just rewrite it, it will be in a standard form. Yeah, so we write this as y prime. Instead of writing negative y over x, I will write negative 1 over x, right? And then y. It's better that way, right? Now, that. So this in the standard form. Yeah, I'm not going to use red anymore. Look, I'll use different color, but try something else. Use black in this, black ink in this case. Right. So this in the standard form, p of x is equal to negative 1 over x. Next, integrating factor. Mu equal to e to the integral p of x dx. And so we have a integral of negative 1 over x dx. 1 over x integral is ln, just like the last one, right? We did, yeah. No, I mean, the first example, integral of 1 over x is ln of x dx. ln of x plus c, sorry. That absolute value of x. Right. So this gives us e to the negative ln absolute value of x. Right. Now, the negative can move on the outside. So we move the negative. And in ls, in ln cancel out. We just have x, absolute of x to negative 1. Right? Or which we can write as 1 over absolute value of x. Right? To the negative 1, move to the bottom becomes absolute value to the first power. So 1 over absolute value of x. Right. So that is the integrating factor. Of course, we multiply on both sides. However, on this one, we do not need the absolute values. Why is that? Right. Let me ask you this. You remember the previous section, right? What happened if we want to get rid of absolute values? What do we do if we want to remove the absolute values? So, the definition, where was that? I just write that somewhere, right? Oh, right here. Absolute value of x is equal to x. If it is greater than or equal to 0, is equal to negative x. If it is less than 0, this is not negative x, it is opposite to x. So if we want to drop the absolute values, it could be positive or negative. So we can replace this by positive or negative. So let's say I can use the integrating factor as plus or minus 1 over x. So instead of absolute values, I write plus or minus, right? Right. Now I multiply this integrating factor on both sides of this equation. Plus or minus 1 over x plus or minus 1 over x plus or minus 1 over x I don't know how I write like that. It's completely off, sorry. Yeah, sorry about that. Now, let's say if we want to get rid of absolute values, replace that with plus or minus. That's what we did in the previous section. Now, when we have this, once again, because we have the equation, right? So once again, we can just, if all of them are negative, we just get rid of all the negative across from left to right. If it's positive, we can get rid of all of that. So meaning that we can just divide by the plus or minus on both sides. So just get rid of that on both sides. So because the nature of the integrating factor is to be multiplied on both sides, whether we have the constant c, what's that? Whether we have the constant c or not, it turned out to be a constant multiplier where we can simplify on both sides. Or whether we have the plus or minus on both sides, they still cancel out. Whether we have an extra constant or whether we have a plus or minus, it will cancel on both sides. Because the nature of integrating factor is to be multiplied on both sides, we can just get rid of absolute values without any problem. So in this case, because I just explained, so write a little note here. For integrating factor, we don't need the plus or minus, or we don't need the absolute values. We can get rid of that. We can remove absolute values. Without putting the plus or minus. Because, like I said, the nature of integrating factor is to be multiplied on both sides. So when we multiply both sides, the constant c will cancel out, the plus or minus will be cancelled out. Yeah. So this little thing did not, like I said, I read for about 4 different textbooks in differential equation to put this note together, and I think only one of them actually mentioned about something like this, because it is multiplied by both sides. When we multiply both sides, they will be cancelled out. Right. Bottom line is, from here, integrating factor is just 1 over x. So in this case, we say the integrating factor is just 1 over x for this problem. Right, we have integrating factors multiplying both sides. So 1 over x y prime minus 1 over x y. Oh, there's still 1 over x, right? Yeah, multiply on both sides to this equation. Right. Now, the left-hand side, though, when we do a lot of this problem, it turns out just the integrating factor and y. So, yeah, we don't even need to simplify this. We know the left-hand side will turn into the integrating factor times y, all of that under the derivative. So that is the product rule. The left-hand side will turn into just that. The right hand side, x and x cancel out. We have just e to the x. Right. In the lecture, I do some easy example. In the homework, you may have integration by parts. The integration might be a little more complicated. But the idea here is just integrating factor multiplying both sides. Yeah. Right, so derivative. To get rid of the derivative, of course, antiderivative or integrate. So the integral undo the derivative. So on the left hand side we have 1 over x, y, and just integral of e to the x dx. And they will say, yeah, the sample in this section I realized that a little bit simple. In the homework it might be more complicated, but it's still integration. If you have any question, please send me an email. Or you can schedule, let me know when we can meet during my office hour and when we can do any complicated integration by parts or any complicated problem. But in class, just want to keep the basic, so we get the idea across about how do we integrate this. If I throw in all the integration by parts, very complicated example, you might lose the step what we actually need to focus on. By the way, on the next example, in the next few chapter for the remainder of the class, you will see the problem will be a lot more complicated than this. Right, so integrate e to the x, it's just integral of e to the x, just e to the x plus c. Yeah, this step we need the constant c. And finally, to solve for y by itself, multiply both sides by x to get y by itself. And also, your solution doesn't have to write all the steps like I do here. I write all of them, so it's easier for you to follow it. Right, multiply both sides by x. And x cancel out, so y equal to x e to x plus c. Right, so that is the general solution. We haven't considered the initial condition here. So when x equal to 1, y equal to that. Right, so I'm going to put 1 in for x and let that equal to y. So y is e minus 1. That is y, and x is equal to 1. Right, simplify, we have e minus 1 equal to e plus c. So obviously from here we c has to be equal to -1, right? So c equal to -1. And I will substitute that into this equation. And I have the solution. Y equal x e to the x. C is -1. Right. So that's what we have for this problem. Right. It's not that bad. Right. This will be the same thing, initial value problem. So let's do that. Right. So this equation is not in the standard form. So the first thing we need to do is get the y prime by itself. Standard form, we start with y prime. So divide everything by x squared on both sides. By the way, this problem, you can continue the space on the next page. If you bring out the note, should be perfectly fine about that. So first of all, divide by x squared on both sides. Yeah, divide by x squared everywhere. So we have y prime plus x over x squared is 1 over x y minus 5x to the 5th power 5x to the 4th equal to 0. By the way, since we don't need the whole page, just fold that in half and just rather continue on the other half of the page. Right, and move that to the other side. Right. In the homework, the integration, this step may be a little more complicated. If you get stuck, please send me an email, or we can always meet in office hour to do any complicated problem that we have. Right. Next, this is in the standard form, right? So in the integrating factor, so p of x equal to 1 over x, and integrating factor is mu of x equal to e to the integral px dx. Even though we have the formula for the solution, but we derive the problem every time. Sometimes when we do this, it's a good practice, and it is much better to just derive from step by step, so easy to check for the mistake. So mu of x e to the integral of 1 over x dx, of course, which is ln of x, ln absolute of x plus c, but we don't really need the constant c. Right, don't need the constant c here. And in ln cancel out the absolute of x. And just like last problem, usually if we have an integrating factor, the nature of that is to be multiplied on both sides. So with absolute values, just get rid of that, and we just use x. Besides, in this problem, it's nice enough that they give us x is greater than equal to greater than 0. X cannot be equal to 0, right? Because if x equal to 0, divided by 0 is undefined. So they're nice enough to give us that. In the previous problem, they didn't give us that. But regardless, even where we have x greater than 0 or x less than 0, I'm just don't need the absolute values here. So integrating factor, it's just x. Yeah, don't need the absolute values. Right, multiply both sides and then just integrate. Yeah, not gonna write all the common every step, so we just multiply x on both sides. And then you say, why don't we just simplify from the step, and then, yeah. But anyway, just get to the standard form and then integrate, even though we just multiply x here, and that seems to work just fine. Anyway. Oh. Sorry, now I see there's a problem. We divide by x squared, right? X to the 5th divided by x squared. Sorry about that. x to the 5th divided by x squared, so that should be x cubed. Yeah, and also when I do this problem, I just bring out, I never do anything, and if this before class. So then so the flow, the class will be, they have more natural flow to it. If I do everything and I would do it out memory, and it is not very good. So whatever the problem I'm doing in class is follow the logic. Anyway, so the left hand side we'll have the integrating factor, which is x times y inside the derivative. That's the product rule. Yeah, integrating factor and y inside the derivative. The right hand side, 5x to the 4th. Right. Now get rid of the derivative, integrate both sides. Yeah, integral, get rid of the derivative. So have x, y equal to 5x to the 5th over 5 plus c. Right. Even though I did not do the problem before class, actually this is a problem that I did in the last year actually. So before that I actually look at the answer and see what the answer is supposed to look like. So yeah, even though I didn't memorize all the steps, at least I know what the answer is supposed to look like, so easy to check. So I have x, y equal to x to the 5th plus c, and divide everything by x. So we have y equal to x to the 5th. Now we divide by x on both sides. Yeah, x and x cancel here. So that gives us, we say x to the 4th plus c, x to the -1. So that's good there. Now this is initial value problem. So meaning when x equal to 1, y is equal to 3. And substitute in this equation, y is equal to 3, x is equal to 1. Right. 1 to the 4th power is still 1, and that's still 1. So 3 is equal to c plus, 1 plus c. So c is equal to 2. So with that, but like I said, we have space on the next page. With that we have, so y, we can say y sub x equal to x to the 4th. C equal to 2, substitute in here, x to the 4th plus 2, x to the -1. Right, so that is our solution. And then you say, why do we need all this space for? Well, yeah. So what we did in this problem, we integrate both sides. And now I want you to focus on this step where we undo the derivative we integrate both sides, right? That's perfectly fine. But in this case, instead of using the integral, we can integrate both sides using the definite integral with the initial condition. So I will write this note here. Note. So instead of integrate both sides, integrating both sides, indefinitely, meaning there's no limit in the integral. We can integrate definitely, or we can integrate with the limit, and the limits come from the initial condition. So the problem has to be initial variable problem to have the initial condition. So if it is not, if there's not initial variable problem where we don't have initial condition, we cannot do this. This only works if it is, it has the initial condition with limits from initial condition. So what I want you to focus on is this step here. But because we're going to put x on the limit, I have to put t in there instead. So instead of x, y, I have to write t instead of x. Use different variable for x. Right. So instead of doing this, I will write again, instead of x, y prime, that I will rewrite this step, but with t instead of x. Some other variable, u or whatever, it cannot be x. So I will say t, y, and of course the function of t, you can say y of t, but I just say t, y, with derivative equal to 5x. Let's say that, replace that with t, because we're going to put the x in the limit. Right, so that is this equation. So what we do is we integrate both sides. With respect to the variable, of course, which is dt. Now, what do we put on the limit? Initial condition. The initial condition was 1 equal to 3, so the variable is equal to 1. And that's the reason we call that initial condition, right? Initial is where it starts. So we go from 1 to x. Because we put x on the limit, so that's why we have to change this to something else. That's the whole reason of changing this to some different variable, because we want to put x on the upper limit, and 1, because it is the initial condition, it starts from 1, so we put from the integral from 1 to that. So still, the integral still undo the derivative, so that just gives us t and then y. By the way, this is not y, it is y of t, so just write y is the function of t. Right, so we evaluate from x from t equal to 1 to t equal to x, and integral of this one is t to the fifth, where t equal to 1 or t equal to x. Yeah. So instead of doing indefinite integral, we do definite integral, where the limit, the lower values is initial values and of x, and the high values is just a variable x. Right. So I put x in here for t. So we have x, y sub x. Again, this will be y sub x minus, now we put 1 in for t, y sub 1. Yeah. To be more precise, we can say this is the function of t. I think I mentioned this before. Usually when I do math, I write everything in pencil, but it's difficult to see in pencil. So instead of y, that is the function of t. Yeah. So put x in for t, then put 1 for t. That's what we have. Same thing, put x in for t, and put 1 in for t. Right. The initial condition y sub 1 equal to 3, right? And that's what we have here. So I have x, y sub x minus 1 times 3 equal to x to the fifth minus 1. So that is 3 plus 3 on both sides. So I have x, y sub x equal to x to the fifth plus 3 on both sides plus 2. 3 minus 1 is 2. And then divide by x on both sides. So y sub x equal to x to the fourth plus 2 over x. Yeah, or the solution can be written like that. So when we have initial condition, we can just write like that. Yeah. Usually I don't want to do this because sometimes it's nice to have the equation in the, have the solution in the general form with a constant as well. Yeah. But either way, we should have the same solution. Right. Now, the way we write like this actually very helpful, because sometimes we have the function that is extremely complicated like that, then we cannot integrate. So that's why I said sometimes the integral do not have solution in terms of elementary function, meaning that we cannot integrate using all the function that we know, namely all the power of x, trigonometric function, exponential function, logarithmic function. That's pretty much it, all the function that we know. If the answer cannot be given in any of those functions, then we just say we just don't integrate at all. Right, so let's look at this problem. Y prime plus y equal to square root of 1 plus cosine square of x. Right, same thing, that is in the standard form, p of x is equal to 1. So this one is standard form. P of x equal to 1. Now just integrate both sides, integrate factor. Integral of 1 is just x. Right, just e to the x. Right, multiply that both sides. Also, I have the habit of writing things in different, marking different colors like this. So it's easy to bookkeeping. Later on, we not only that, we have to mark so something just to help us more organize around a little bit better. But for now, it doesn't really matter. Like I said, usually I just write everything in pencil. Right, now the left hand side has integrating factor and y in the under the derivative. Right, this doesn't look like something that I can integrate. So in that case, I'm use what we did earlier. I'm going to integrate both sides definitely with the limits based on the initial condition. So before I do that, I have to replace everything with t. That t. Right. Now instead of integrate both sides without the limit, I'll integrate from the initial values of x is 1, go to x. Still though, that case t is a variable. Still, integral undo the derivative. And on the right hand side, we cannot integrate this in terms of the function that we know. So I'm just going to leave it at that. Put x in here, put 1 in here. E to the x, y sub x, subtract e to the first, y sub 1 equal to that integral. Right, e to the first is e and y of 1 is 4. That's what given. So we have, I'm going to move 4e to the other side. So e to the x times y of x equal to the integral and then we have 4e move to the other side, that minus, so plus 4e. And then finally, if we want y by itself, just divide both sides by e to the x. Or we say y sub x equal to 1 over e to the x integral right. Like I said, because we cannot integrate, so that's why we stop with just that. Right, and finally, to finish the section up, we have the theorem about existence and uniqueness of solution. It says that if p of x and q of x are continuous on the interval a, including a and b, containing the initial point x naught, then for any choice of y naught, there is a unique solution for the initial value problem. So at this level, if you can solve the equation, I'm more than happy about that. The uniqueness and existence and uniqueness is a little more advanced when we go into higher level. But at this level, if you can solve the equation, I'm more than happy about that. So, linear first order equation. First, it has to be in a standard form, so we can write the integrating factor. Integrating factor, by nature of that, multiply on both sides. So absolute values, we can get rid of that. The constant can get rid of that. So that's why we just have that, multiply both sides. When we multiply to the left hand side, the integral becomes the integrating factor times y under derivative. Because both of them under derivative, to get rid of the derivative, we integrate both sides. The problem depends on whether we can integrate the right hand side or not. If it is too complicated like this, we're just going to leave it as the integral. Right. And also, if this is initial value problem, we can integrate both sides with the limit. Lower limit is the initial values of x, the high limit is x. Because initial value problem, initially it starts from here to something else. Right. So with that, I stop section 2.3 here. Like I mentioned at the beginning of the section, this is one of the more important section of differential equation. Alright. See you in another video in differential equations. As always, thank you for watching.